So let's look at the second example. We want to solve in the interval between 0 and 360 degrees for 5 sin x minus 2. So we're always going to solve to find our x. So find our principal values first. So find your principal value. So we're just going to solve the equation 5 sin x equals to minus 2. Therefore, sin x is the same as minus 2 over 5. Therefore, x is equals to minus sin minus 1 to the minus 2 over 5. And this value is equals to minus 23.6 degrees to 3 SF. So you always find your principal values from your calculator. So I prefer to use method 2. I think that's the easiest way. So as we're looking at sine, so I'm going to sketch my sine curve. Since this is minus, so I'm just going to sketch the negative part as well. So your sine always start from 0, goes up to 1, then goes down to 0, then minus 1. So here's a sketch of my sine curve. So 0 intersects at 180, 360, and minus 180. The maximum it goes is 1, and the smallest value it goes to is minus 1. So this is my sine curve. So what I'm interested is when sin x is same as minus 2 over 5. So minus 2 over 5 is approximately here. So this is minus 0.4. So this is minus 0.5. So it's approximate this region here. So I'm just going to draw a line here. So let's say this is approximately 0.4. So this point here is going to be my minus 23.6. But I'm not interested in this point. I'm interested in my values here between 0 and 360. So I want to find those two values here. So I can find out this value first because I know my curve repeats every 360. So all I have to do to find the first value, I use my principal value plus 360, which is equals to 336.4 degrees. So I know this is the first point here. So that's one of my values. Then I need to find this value as well. So how I think about finding this value here is that from this point, so from 360 to this point here, I know the distance is minus 23.6. Because this distance here from 0 to this point here is minus 23.6. And since I know my curve is symmetrical, therefore, so I know this part here must also be 23.6. So I need to do 180 plus 23.6. And this is equals to 203.6 degrees. So here's my values between 0 and 360. Let's look at one more example. So find the values of theta in the interval 0 to 360 that satisfies this equation here. So again, we always start by finding our principal values by solving our equation. So I have my sin theta equals √3 over cos theta. So from our previous lesson, we learned at the start of the lesson, we have learned that tan theta is the same as sin theta over cos theta. So we're just going to rearrange our equation. So sin theta divided by cos theta is equals to √3. And we know this is the same as tan theta equals √3. So now we can find our principal value. Theta is equals to tan minus 1 √3. And this is the same as /60. So let's do a sketch of our tan curve. So this is a sketch of a tan curve, and it goes for infinite. So what we're interested is when tan theta is equals to √3. So √3 is approximately 1.73. So let's say this is 1. So let's say 1. So let's say here is about √3. So this point here is √3. So we're interested in when tan theta is √3. So we know this is the first value we found, which is 60 degrees. And we know that our tan curve repeats every 180 degrees. So we're going to add 60 plus 180. And this is equals to 240. So we know this point here is 240. So our two values are 60 and 240.